Alright guys, section 5.1, we're going to start out with some vocabulary. I've put mine in a chart format so that we can have our word, our definition, and our examples over here. You can put it in a chart format, or you can just write the definition and the examples underneath, however you want to do it on your paper. So where we're going to start is with the word monomial. A monomial is simply a number, a variable, or the product of numbers and variables. Okay, and then I need to give you some examples of those. So, first example, 3 is a number. -7's just a number. X and A are variables, but you could use any letter. 2x is the product of a number and a variable. -5xy, that's the product of a number and more than one variable, but it is still a monomial. 1/2 x and x over 2. Those are all examples of monomials. These two things right here, 1/2 x and x over 2, mean the exact same thing. They're just written differently. Now, there is something that you cannot have when we're dealing or when we're talking about a monomial. There can be no variables in the denominator of a fraction or under a radical. So you can't have like the square root of x. Also, when you are talking about a monomial, that is just one term. You don't have stuff added and subtracted together, it's just one thing, even if it's a product. Right. So now we're going to take a look at the degree of a monomial. And we're going to focus on monomials that only have one variable. Okay, something I want you to look at over here. This is still a monomial, that -5xy. It is a monomial, but it has more than one variable. But in all the rest of this chapter, we're only going to focus on one variable at a time. Okay. So, what is the degree? That is equal to the exponent of the variable. Now this degree tells us something about the graph. What it tells us is the maximum number of times it can touch the x-axis. I'm going to go ahead and list some examples out here to the side, and I'll give you a second to get caught up, and then we will go back and talk about these examples. Examples out here. We need to figure out what the degree for each of those is. So for 7x cubed, what is the exponent for that variable? 3, so that is a third degree. When I have 2 cubed y squared, what is the exponent for the variable? 2, so that one is a second degree. For 5x, what's the exponent for that variable? 1. It's not written there, but when it's just an x, it's an x to the first power. It's understood, so that is a first degree. And the last one down there, you will never see written in your textbook, in your workbook, or in Math Excel anything ever to the 0 power. I wrote it here just to make a point. Okay, what is anything to the 0 power equal to?
0.
No, it's equal to 1.
Yep.
If we take our calculator and we type in anything to the 0 power, I can type in 4 to the 0 power, I get 1. I can type in 89 to the 0 power, I get 1. I can type in 853 to the 0 power, and I get 1. Yes? Well, okay, I can show you why it's following a pattern. So let me move this here just a second. Think about it. If you've got 2 to the 3rd power, that's 8, right? 2 to the 2nd power is 4. 2 to the 1st power is 2. Each time I'm cutting those in half, right? So now 2 to the 0 power, cut this one in half, you get 1. If you do 2 to the negative 1 power, and we're going to talk about this later in chapter 6, I believe it is, but that ends up giving me 1/2, which is half of that previous one. It's part of a pattern. Okay, so that's why it works that way. Alright, so anything, no matter what it is, anything to the 0 power is equal to 1. So what this really means is negative 3 times 1, which is just negative 3. Okay? So whenever you have a number all by itself, it's like having that number times x to the 0 power. So this is a 0 degree. I'm not sure what's happening over there. Alright, for a polynomial, that is the sum or difference of monomials. Okay, so once again I'm going to give you some examples and then we'll come back and discuss them. Alright, so for this first one, if you take a look, 4x is a monomial, 3 is a monomial, and they're added together. So this is technically 2 terms. If one term is a monomial, what's 2 terms? Binomial. Right, for the next one, how many terms does it have? 3. What do you call it if it has 3 terms? Yep. Okay, the next one has how many terms? 4. And this is where the special names for that kind of goes away. If you have 4 or more terms, it is just called a polynomial. And this one is a polynomial of 4 terms. Right. And the last one, how many terms is that? 3. And what do you call that again? Yep. Y'all okay? Alright, so we already talked about the degree of a monomial. Now we're going to talk about the degree of a polynomial. And again, we're only going to deal with one variable. The degree of a polynomial is equal to the largest exponent for a variable. And this tells us something about the graph. Okay, just like with the monomial, it will tell us how many times it touches the x-axis, but it also helps us to determine if the 2 sides of the graph, the left side and the right side, it helps us determine if they go the same direction or opposite directions. And that will make more sense in a few minutes when we actually start looking at some graphs. The examples we're going to use here are the same examples we used before. We're just going to talk about different parts of those examples. So just go ahead and recopy them. Alright, so when we're looking at this problem, in the first one, this is the only x there is in that problem. And it is an x to the first, so this one is a first degree. Because I'm just looking at that x to the first power. In the next example, I have an x squared and an x. Which one's the bigger exponent? X squared, so that is a second degree. In the next one, I've got an x to the third, an x squared, and an x. Which one's the biggest exponent? X to the third, x cubed, so that is a third degree. Now in the last one, I have an x squared and an x to the third. Which one's bigger? X to the third, so this is also a third degree. Now something I want you to notice, that in all 3 of these first ones, it just so happened that it was the first term that told us what the degree was, and that's because each of those all started with the biggest exponent. and then worked its way down smaller. That's called standard form, or descending order. This one's not written in that order. You could rewrite it in that order if you want to, but you don't have to. You just have to find the biggest exponent for x. All right, anybody still copying? All right, one more term, and this is for the leading coefficient. All right, so this is the coefficient of the degree term. Okay, the easiest way to find the leading coefficient is to rewrite so that your equation is in descending order. Then it's the first one. The leading coefficient also tells us something about the graph that we will look at in a few minutes. But what it tells us is it determines if the right side of the graph points up or down. Alright, the examples we're going to use are the same ones we've used for the last two. Alright, so just like we talked about a few minutes ago, these first three are written so that they are in descending order already. Because they are written in descending order, I just picked the very first coefficient for each of those. So for this one, my leading coefficient is 4, and more importantly, it's a positive 4. I really care more about whether it is positive or negative than I do about the number. Okay, for this one, your leading coefficient is a positive 7. This one, it's a positive 9. For the last one, it's not written in descending order. So that's where you've got to take a look at this. This is the term that told us it was a third degree. So I need the coefficient for that term. So that is a positive 5 leading coefficient. So you can do it that way, or you can rewrite so that it's in descending order. Okay, in that case, we would start with the term that has the biggest exponent. So that's 5x cubed. The next biggest is 7x squared, and then our negative 2. If you rewrite it so it's in descending order, you're going to pick the very first one, which is still a positive 5 leading coefficient.